Tonight, we're going to explore a question that sounds simple at first, but becomes stranger the longer you sit with it. How fast are you actually moving right now? Not metaphorically, not in the sense of life moving quickly or days slipping by, but physically, truly, in this exact moment. Because although it might feel like you're sitting still, perhaps lying in bed, maybe resting your head on a pillow or leaning back in a chair, there's a good chance you're moving faster than anything you've ever experienced consciously. Faster than a plane, faster than a bullet, faster even than anything you've ever seen with your own eyes. And yet, you don't feel a thing. Before we ease into that idea, let me ask you something simple, just as a small anchor before we drift too far. Where are you listening from right now? And what time is it in your part of the world? It's a slightly curious question, considering what we're about to talk about. Because while you might answer with a city, a country, maybe even a specific room, the truth is, that location isn't as fixed as it seems. If this little journey turns out to be something you enjoy, something that helps you relax or unwind after a long day, then feel free to give the video a like or subscribe if you'd like to return to this quiet corner again. It helps more than you might think. Now let's begin gently. Imagine for a moment that everything around you simply paused, not slowed down, not faded, just stopped. No sound, no motion, no shifting light, completely still. Would you notice anything unusual? At first, probably not. Stillness is familiar. It's what we expect when we sit down, when we lie still, when we close our eyes. It's what we call rest. But here's where things begin to feel a little strange. Even in that perfectly still moment, you would still be moving. In fact, you are moving right now, even as you read or listen to this, at speeds that are almost difficult to imagine. The reason it doesn't feel that way comes down to something surprisingly simple. Motion, as we experience it, isn't about how fast you're going. It's about whether that speed is changing. If you're sitting in a parked car, everything feels still. If that car begins to accelerate, you feel pushed back into your seat. If it brakes suddenly, you feel pulled forward. That sensation, that awareness of motion, comes from change. But if the car moves smoothly at a constant speed, especially on a long straight road, something interesting happens. After a while, it begins to feel like you're not moving at all. You could close your eyes, and without the hum of the engine or the slight vibration beneath you, you might not even know the car was in motion. That's because your body isn't designed to detect constant speed. It detects changes in speed, acceleration, deceleration, shifts in direction. Without those, motion becomes invisible, and that's exactly what's happening to you right now. The ground beneath you feels solid, unmoving, reliable. But it's not stationary. It's carrying you along on a journey that never stops, not even for a second. Let's start close to home. The Earth, the planet you're sitting on right now, is rotating. It completes one full spin roughly every 24 hours, which is why we experience day and night. But that gentle, familiar cycle hides something quite remarkable. At the equator, the surface of the Earth is moving at about 1,670 kilometers per hour. That's over 460 meters per second. To put that into perspective, that's faster than the speed of sound in air under many conditions, faster than a commercial jet at cruising speed, and yet you don't feel like you're spinning. Why? Because everything around you is spinning with you. The air, the ground, the buildings, the oceans, even the atmosphere extending far above the surface. You and everything you can see are part of the same system, moving together at the same speed. There's no sudden push, no jolt, no change in direction that your body can detect. It's a smooth, continuous motion that has been happening your entire life, and long before that. It's a bit like being on a perfectly smooth carousel that never speeds up or slows down. If you were placed on it gently, without any initial movement, you might not even realize it was turning. Now, depending on where you are on Earth, that speed changes slightly. If you're closer to the poles, The distance you travel in one rotation is smaller, so your speed is lower. Near the equator, it's fastest. Somewhere in between, it adjusts gradually. But no matter where you are part of that rotation. You're being carried along by the Earth's spin, whether you're walking, sitting, or lying completely still. And still, nothing feels unusual. That's because your body has no reference point to compare against. Everything in your immediate environment shares that motion. But the rotation of the Earth is only the beginning. Because while the Earth spins, it's also doing something else at the same time. It's orbiting the Sun. Now, this motion is a little harder to picture because it unfolds over a much larger scale. The Earth completes one full orbit around the Sun every year. That's the cycle we measure as 365 days. But the distance involved is enormous, and to cover that distance in that amount of time requires a very high speed. On average, the Earth travels around the Sun at about 107,000 kilometers per hour. That's nearly 30 kilometers every second. Every second. Which means that in the time it takes you to blink, you've already moved dozens of kilometers through space, and again, you don't feel it. The same principle applies. Everything on Earth, including you, is moving along with the planet. There's no sudden acceleration, no noticeable shift. It's a smooth, continuous path through space. If you could somehow pause the motion of the Earth's orbit while everything else continued, the effect would be immediate and dramatic. But because you are part of that motion, because your entire frame of reference is moving with it, it feels like stillness. This is one of the quiet tricks of the universe. Movement without sensation, speed without awareness. You might think of motion as something dramatic, something you notice, something that pushes against you or carries you forward. But most of the motion you experience is silent, constant, and completely hidden from your senses. And what makes it even more interesting is that these motions are layered. The Earth is spinning, yes, but it's also orbiting the Sun. And the Sun itself is not standing still either. It's moving, carrying the entire solar system with it. So even as you sit quietly, perhaps thinking you are perfectly still, you are participating in multiple overlapping motions at once. You are spinning with the Earth. You are travelling around the Sun, and you are being carried through the galaxy, all at the same time, and none of it feels like motion. Take a moment to notice that. There's something slightly comforting about it, isn't there? The idea that even when you feel like nothing is happening, something is always in motion. That stillness, as we experience it, is not the absence of movement, but simply the absence of change in that movement. If you were to stand up right now and take a few steps, you would feel that motion immediately. Your muscles engage, your balance shifts, your body registers the change. But compared to the speeds we've just mentioned, those steps are incredibly small. A walking pace might be a few kilometers per hour, a gentle jog, perhaps a bit more, and yet those are the movements you feel, not the thousands of kilometers per hour beneath you, not the silent journey through space. It's a reminder that your perception of reality is not a complete picture. It's a filtered version, shaped by what your senses can detect and what your brain considers important. Constant motion fades into the background. Change stands out. And so, as you settle a little deeper into wherever you are right now, whether you're listening with your eyes open or closed, you can carry that thought with you. You are not still. You have never been still. Not for a single moment. Even in the quietest, most peaceful pause, you are moving in ways that are vast, continuous, and entirely unnoticed. And as we continue, we'll begin to unfold just how many layers of motion are stacked beneath that simple feeling of rest. At first glance, stillness feels obvious. You sit down, you stop walking, you rest your head, and everything seems to settle into place. The room holds steady, the walls don't shift, the floor stays exactly where you expect it to be. There's a quiet agreement between your senses and your surroundings that says, nothing is moving right now. And yet, as we gently uncovered just a moment ago, that feeling isn't quite telling the whole story. Because even when everything appears calm, even when your body feels completely at rest, there is motion happening beneath that calm. Constant, smooth, uninterrupted motion. So why don't you feel it? The answer begins with something surprisingly simple. Your body doesn't detect speed, it detects change. That distinction might seem small at first, but it explains almost everything about why motion can disappear so completely from your awareness. Think about a moment you've experienced before, sitting in a car, perhaps on a long highway. At first, when the car begins to move, you feel it immediately. The push as it accelerates, the slight shift in your posture, the sensation of movement pressing against you. But after a while, once the speed becomes steady, something interesting happens. The sensation fades. If the road is smooth enough, if the motion is consistent, it can begin to feel almost as if the car has stopped. You might look down at your phone or out the window, and unless something changes, you could forget entirely that you're moving at all. The only time that awareness returns is when something shifts again. A turn, a bump, a sudden brake, a gentle acceleration. It's not the motion itself that you feel, it's the change in motion. Your body is equipped with systems designed to notice acceleration. Inside your inner ear, there are tiny structures filled with fluid that respond when your speed changes or when your direction shifts. They act like sensors, quietly monitoring how your body moves through space. But when everything is moving smoothly, at a constant rate, those sensors have nothing to report. No change, no signal. And without that signal, your brain assumes stillness. This is why you can sit on a plane travelling at hundreds of kilometers per hour and feel completely at rest. The cabin is stable, the motion is constant, and your senses have no reason to raise any alarms. It's also why turbulence feels so noticeable, not because the plane suddenly becomes fast, but because its motion becomes uneven. Your body notices the change. Now, bring that idea back to where you are right now. The Earth's rotation is incredibly smooth. There are no sudden starts or stops, no sharp turns, no jolts that would alert your inner ear. It has been spinning at a steady rate for billions of years. From your perspective, it might as well be standing still. The same is true for the Earth's orbit around the Sun. It's a continuous, graceful motion guided by gravity, with no abrupt shifts in speed or direction. And because everything around you is moving with that same motion, there is no contrast, no reference point that would allow you to notice it. This brings us to another important idea. Motion is always relative. To understand whether something is moving, you need something else to compare it to. If you're sitting in a train at a station and another train begins to move beside you, there's often a brief, slightly confusing moment where you're not quite sure which train is actually moving. For a second or two, it can feel like you're drifting backward, even if you're completely still. That's because your brain is trying to interpret motion based on relative cues. It looks at what's changing in your environment and uses that to decide whether you're moving or something else is. Without a clear reference point, that interpretation can become uncertain. Now imagine removing all external references entirely. No nearby objects, no shifting scenery. Just you, moving smoothly through space, surrounded by things that are moving exactly as you are. In that situation, motion becomes invisible. There's nothing to compare against, nothing to measure change. And so, your brain defaults to stillness. This is the situation you're in right now. Everything you can see, everything you can touch, everything around you shares the same motion as you. The ground beneath you, the air around you, the buildings, the trees, even the clouds above. They're all part of the same system, and because of that, there is no relative motion between you and your immediate surroundings. From your perspective, nothing is moving. But step outside that shared system, even just in your imagination, and the picture begins to change. Imagine you could pause everything around you except yourself. The Earth stops spinning. The air becomes still, the entire environment freezes in place. But you continue moving at the speed you were already travelling. Suddenly, the illusion would vanish. You would feel the wind rushing past, the ground slipping beneath you, the overwhelming sensation of motion that was always there but hidden. Of course, that scenario isn't something we can experience directly. but it helps illustrate how much of what we perceive depends on comparison. Without contrast, motion fades into the background. And there's another layer to this as well. Your brain is constantly filtering information. At any given moment, there is far more sensory input than you could ever consciously process. Sounds, textures, temperatures, subtle shifts in balance. Countless details flowing in all at once. If your brain tried to pay attention to all of it equally, it would quickly become overwhelmed. So it prioritizes. It focuses on what changes, what stands out, what might require a response. Constant, unchanging signals are gradually tuned out. You've probably noticed this with sounds. A fan humming in the background, the quiet buzz of a refrigerator, distant traffic outside a window. At first, you might hear it clearly, but after a while it fades, not because the sound has stopped, but because your brain has decided it's not important. Motion works in a similar way. The constant movement of the Earth, the steady orbit around the Sun, the larger motions we'll soon explore, all of these are consistent, predictable, and unchanging from your immediate perspective, so your brain lets them go. It treats them as background, and what remains is the feeling of stillness. There's something quietly fascinating about that, isn't there? The idea that stillness isn't necessarily the absence of motion, but the absence of noticeable change. That your sense of being at rest is not a direct reflection of reality, but a carefully constructed experience, shaped by how your body and brain interpret the world. It also explains why certain types of motion feel so different from others. Sudden acceleration feels intense. A quick turn can make you dizzy. A drop in an elevator can create that brief, weightless sensation in your stomach. Those are all changes. Your body is responding exactly as it's designed to. But steady motion, no matter how fast, slips past unnoticed. You could be moving at extraordinary speeds, and as long as that motion remains constant, it becomes almost indistinguishable from being completely still. This is why astronauts in orbit often describe a sense of floating calm, despite travelling at tens of thousands of kilometers per hour around the Earth. Their motion is smooth, continuous, and shared with everything around them. From inside their spacecraft, it feels like quiet stillness. And in a way, that's exactly what you're experiencing right now. A kind of grounded version of the same phenomenon. You're part of a system that is moving together smoothly and continuously, without interruption. There are no sudden shifts to draw your attention, no contrasting motion to reveal what's happening, so your senses remain quiet, and your mind interprets that quiet as stillness, and even as you remain right where you are, comfortable, settled, and at rest, the journey continues quietly beneath you, carrying you forward without ever asking you to notice. Let's bring our attention a little closer again. Not out to the vastness of space just yet, not to distant stars or galaxies, but to something much more familiar, the ground beneath you. It feels steady, doesn't it? Reliable, solid, exactly where it should be. If you were to place your hand on a table or press your feet gently into the floor, there's a quiet sense of certainty there. Nothing is shifting, nothing is sliding away, nothing suggests that you're moving at all, and yet, quietly, continuously, and without pause, the entire surface beneath you is turning. The Earth is spinning. Not slowly, not gently in the way it feels, but at a speed that would seem almost unbelievable if you were to experience it directly. Let's take a moment to unpack that. The Earth completes one full rotation approximately every 24 hours. That's the familiar cycle we experience as day and night. The sun appears to rise, travel across the sky, and set again, marking the passage of time in a way that feels natural and predictable. But that daily rhythm hides something much more dynamic. The Earth isn't just turning in place like a stationary object gently rotating on a table. It's enormous, and because of that size, the outer edges of that rotation move incredibly fast. Imagine drawing a circle. The larger the circle, the longer the path around its edge. If you spin a small object, the distance covered in one rotation is small. But if you spin something the size of a planet, the distance around it becomes vast. At the equator, where that distance is greatest, the circumference of the Earth is about 40,000 kilometers. Now, if that entire distance is covered in 24 hours, the speed works out to roughly 1,670 kilometers per hour. That's faster than most commercial airplanes. It means that if you were standing at the equator, you would be travelling eastward at that speed simply by standing still. No effort required, no sensation, just carried along by the rotation of the planet. Even if you're not at the equator, even if you're somewhere farther north or south, you're still part of that rotation. The speed changes slightly depending on your latitude, becoming slower as you move toward the poles, but the motion never stops. Wherever you are right now, you are turning with the Earth. And it's been happening your entire life. From the very first moment you experienced anything at all, you were already in motion, already part of this continuous spin. There's something quietly reassuring about that, isn't there? The idea that beneath everything you do, beneath every thought, every step, every pause, there is this steady, dependable movement carrying you along. But it also raises an interesting question. If the Earth is spinning that fast, why doesn't it feel like it? Why aren't we aware of that motion? The answer, as we began to explore earlier, comes back to smoothness and consistency. The Earth doesn't suddenly start spinning each morning and stop at night. It doesn't speed up or slow down in any noticeable way. Its rotation is incredibly stable. Because of that, there's no acceleration for your body to detect. Your inner ear, the part of your body responsible for sensing motion and balance, is tuned to notice changes. It responds when you turn your head, when you accelerate, when your direction shifts. But constant motion, no matter how fast, doesn't trigger that response. So as the Earth turns, your body simply moves along with it, quietly, effortlessly, without any signal that something is happening. There's also another important detail. The air around you is moving too. The entire atmosphere is carried along by the Earth's rotation. The winds we experience, the gentle breezes or stronger gusts, are layered on top of that motion, but the baseline movement of the air matches the rotation of the planet. This means there's no constant rush of wind sweeping past you at 1,670 kilometers per hour. If there were, it would be impossible to ignore. Instead, everything around you shares the same motion. The ground, the air, the buildings, the trees, the oceans, all of it turning together as a single system. From your perspective, nothing is moving. But if you could step outside that system, even just for a moment, the picture would change completely. Imagine hovering in space, looking down at the Earth. From that vantage point, the rotation becomes obvious. You would see the continents slowly shifting, the oceans turning, the line between day and night moving steadily across the surface. What feels still from here would look undeniably dynamic from there. This difference in perspective is at the heart of why motion can feel so elusive. Inside the system, everything appears calm. Outside the system, the motion becomes clear. There's also something interesting about how this rotation shapes our experience of time. Day and night, one of the most fundamental rhythms of life, is a direct result of the Earth's spin. As the planet turns, different parts of its surface face toward or away from the sun, creating the cycle of light and darkness that we live by. Morning arrives not because the sun moves upward, but because your part of the Earth has rotated into its light. Evening comes not because the sun sinks, but because your location has turned away from it. It's a subtle shift in perspective, but it changes how you think about what's happening. You're not watching the sun move across the sky. You're being carried into and out of its light. And that movement is happening continuously, whether you're aware of it or not. Take a moment to imagine that more vividly. Right now, wherever you are, you're slowly turning toward or away from the sun, depending on the time of day. If it's evening, you're gradually rotating out of the sunlight, moving into the darker side of the planet. If it's morning, you're being carried back into the light. And if it's somewhere in between, that transition is still happening, just more gradually. It's a quiet, constant journey that gives structure to your day without ever announcing itself. There's another small detail worth noticing. Because the Earth is spinning, different parts of the planet are moving in slightly different directions at any given moment. At the equator, the motion is purely eastward, but as you move toward the poles, the path becomes more curved, following smaller circles around the Earth's axis. Yet despite these differences, everything remains coordinated. The entire planet turns together, maintaining its shape, its structure, its balance. It's a kind of large-scale harmony, a motion so well integrated that it becomes invisible from within. And perhaps that's one of the most interesting parts of all this. The fastest movements you experience every day are not the ones you notice. They're the ones that remain constant, the ones that never interrupt you, the ones that simply carry you along moment after moment without asking for your attention. As you sit or lie there now, you are completing part of a rotation that began long before you started listening and will continue long after. In the time it takes to drift through these thoughts, the Earth will have turned just a little more, moving you along its surface without any effort on your part. It's happening right now, quietly, smoothly, without any sensation at all. There's a quiet moment you might recognize, sitting in a train, perhaps, as it begins to glide forward so smoothly that for a second or two, you're not entirely sure whether you're moving or the world outside is. The platform drifts past, slowly at first, and your brain hesitates, trying to decide what exactly is happening. Then the motion becomes clear, but only because something changed. Without that change, without that brief shift from stillness into movement, you might never notice it at all. And that, in a way, is exactly what's happening with the Earth beneath you. Because while we've already uncovered just how fast the planet is spinning, the more interesting question is not the speed itself, but the silence of it, the complete absence of sensation, the fact that something so enormous and so dynamic can feel completely still. To understand that, it helps to imagine a slightly different scenario. Picture yourself standing on a vast, perfectly smooth surface that stretches in every direction. There are no landmarks, no trees, no buildings, no mountains, nothing to give you a sense of position. Just an endless, uniform plain. Now imagine that this entire surface begins to move, not suddenly, not with a jolt, but gradually, gently, until it reaches a steady, constant speed. At first, you might notice something, a faint shift in balance, a subtle awareness that something has changed. But once that motion settles, once it becomes smooth and unchanging, the sensation fades. After a while, it would feel exactly like standing still. Because from your perspective, nothing is changing anymore. The ground beneath you isn't moving relative to you, it's carrying you along. And since everything you can see and touch is part of that same surface, there's no reference point to reveal the motion. That imagined surface is, in a sense, what the Earth is doing. You're not standing on something separate from the motion. You're part of it. You're riding the planet. And not in the dramatic sense. Not like holding on to something that's spinning wildly, but in the most seamless way possible. You and the Earth are moving together, locked into the same motion, sharing the same speed, the same direction, the same path. There's no sliding, no resistance, no sense of being left behind or pushed forward. Just quiet, continuous movement. Another way to think about it is to consider how motion feels when it's uneven. When a car accelerates, you feel pressed back into your seat. When it brakes, your body shifts forward. When it turns sharply, you feel pulled sideways. These sensations come from differences. Your body wants to keep moving the way it was, and when something changes that motion, you feel it as a force. But if the car moves at a constant speed in a straight line, something very different happens. Those forces disappear, there's no push, no pull, no sideways drift. Everything inside the car, including you, is moving together at the same steady rate. From the inside, it feels like rest. The Earth's rotation works in a similar way, but on a much larger scale and with even greater smoothness. There are no sudden changes in speed, no sharp turns, no interruptions, just a continuous, stable motion that has been ongoing for billions of years. Your body has never known anything different. From the moment you were born, you were already moving with the Earth. Your senses developed within that motion. Your brain learned to interpret the world assuming that motion as a constant background. So it doesn't register as something unusual. It registers as normal. There's also the matter of gravity, quietly holding everything in place. The Earth's gravity pulls you toward its center, anchoring you to the surface. It keeps your feet on the ground, your body aligned with the planet, and everything around you in its proper place. Without gravity, the experience of the Earth's rotation would feel very different. You might drift, float, or notice the motion more directly. But with gravity acting constantly, it ensures that you remain firmly connected to the rotating surface. You move with it, not across it. And that distinction matters. If you were sliding across the surface at high speed, you would feel the friction, the wind, the resistance. But because you are carried along, because your motion matches the Earth's exactly, there is no relative movement between you and the ground. No friction, no wind, no signal for your senses to detect. Everything simply aligns. There's a small detail here that often goes unnoticed. Even the air you breathe is part of this motion. The atmosphere rotates with the Earth. It isn't left behind as the planet spins beneath it. Instead, it moves along, held in place by gravity and the same forces that govern the rest of the system. This is why you don't experience a constant, overwhelming wind rushing past you from west to east. The air shares your motion. You and the atmosphere are travelling together, and because of that, the world feels calm. There are winds, of course, but those are local movements, differences within the larger system. They're layered on top of the Earth's rotation, not a result of it. The baseline motion remains hidden. Now consider what would happen if something interrupted that smoothness. If the Earth suddenly sped up, even slightly, you would feel it immediately. Your body would respond to the change, your balance would shift, and the sensation would be unmistakable. The same would happen if it slowed down or changed direction. But because none of those things occur in any noticeable way, the motion remains invisible. It's not that the Earth isn't moving fast enough to be felt, it's that it's moving too consistently. There's a certain elegance to that idea. The faster something moves, the more dramatic we expect it to feel. But in reality, it's the irregularities, the changes, the interruptions that create sensation. Smoothness, even at extreme speeds, can feel like stillness. You might think of it like floating in a calm river. If the water is rushing past rocks and creating turbulence, you'll feel every shift and swirl. But if the current is smooth and even, carrying you gently along, the motion becomes almost imperceptible. You're still moving, perhaps quite quickly, but without disturbance. It feels like rest. That's what it means to ride the planet. You're part of a motion so smooth, so stable, and so all-encompassing that it becomes indistinguishable from stillness. And because everything around you shares that motion, there's no contrast to reveal it, no external reference, no signal to your senses, just the quiet assumption that nothing is happening. But something is happening, constantly. You're being carried along by the Earth's rotation, even now, as you sit or lie in place. Every second that passes, you're moving with the planet, tracing a circular path through space, completing a rotation that began long before this moment and will continue long after. And yet, from where you are, it feels like you haven't moved at all. That contrast between what is happening and what is felt is one of the most subtle illusions we live with every day. It doesn't disturb us. It doesn't demand attention. It simply exists in the background, quietly shaping our experience without ever stepping into the foreground. Long before you notice the passing of a single day, before any sense of morning or evening settled into something familiar, another journey was already underway. It doesn't begin when you wake up. and it doesn't pause when you sleep. It doesn't reset at midnight or slow down on quiet afternoons. It continues, steadily and without interruption, carrying you along a path so large that it's almost impossible to picture all at once. While the Earth turns beneath your feet, it is also travelling. Not in a small circle, not in a gentle drift, but in a wide, sweeping path around the Sun, and you are travelling with it. If the daily spin of the Earth is like standing on a slowly turning platform, then this next motion is more like being carried along a vast, invisible track that loops through space over the course of a year. We mark that journey with seasons, with changing light, with the slow shift from colder days to warmer ones and back again. But behind those familiar changes lies something much more dynamic. The Earth is orbiting the Sun at an average speed of about 107,000 kilometers per hour. That's nearly 30 kilometers every second, which means that in the time it takes you to take a single breath, you've already travelled dozens of kilometers through space without feeling any of it. There's something quietly astonishing about that, because unlike the Earth's rotation, which at least has a visible effect in the form of day and night, this motion is even more hidden. You don't see the path you're tracing. You don't feel the speed. You don't notice the constant forward motion. And yet it's happening, continuously, every moment of your life. To make sense of this, it helps to imagine the scale involved. The distance between the Earth and the Sun is about 150 million kilometers. That distance defines the size of the orbit, a vast, nearly circular path that the Earth follows year after year. If you could step far enough away to see it from the outside, you would watch the Earth tracing that path, moving steadily along its orbit, never stopping, never hesitating. But from where you are inside that motion, it feels like stillness. And once again, the reason comes back to the same idea: smoothness, consistency, and the absence of noticeable change. The Earth doesn't suddenly leap forward in its orbit. It doesn't jerk or wobble in a way that your body could detect. Instead, it follows a path guided by gravity, continuously falling toward the Sun while also moving sideways fast enough to miss it. That combination creates a stable orbit, a kind of endless fall that never quite reaches its destination. It's a delicate balance, but one that has been maintained for billions of years. And because that motion is so steady, your body has no reason to notice it. There's no acceleration that stands out, no sudden shift in direction, just a continuous curve through space. You might wonder, though, if the Earth is constantly changing direction as it orbits, why don't we feel that? After all, moving in a circle means you're always turning, even if only slightly. And it's true. The Earth is constantly changing direction as it travels around the Sun. But the scale of that curve is so enormous, and the change so gradual, that it becomes imperceptible. It's a bit like walking along a very large circle. If the circle is small, you notice the turning immediately. Your path curves, your body adjusts, and the motion is obvious. But if the circle is so large that the curve stretches over thousands of kilometers, each step feels almost perfectly straight. The turning is still there, but it's too gentle to detect in the moment. That's the kind of curve the Earth is following. Vast, gradual, and incredibly smooth. And because of that, the motion remains hidden. There's also another layer to this. Everything around you is sharing that same orbit. The ground beneath you, the air around you, the oceans, the atmosphere extending far above, all of it is moving together along the same path. So once again, there's no relative motion to reveal what's happening, no wind rushing past from the direction of travel, no sense of being carried forward, just the quiet illusion of standing still. If you could somehow step outside of that shared motion, even just for a moment, the experience would be completely different. You would see the Earth moving along its orbit, the Sun at the centre, and the vast distance being covered every second. You would watch entire days pass as the planet continues its journey, tracing that enormous path through space. But from here, inside the system, it feels like nothing is moving at all. And yet, this motion shapes so much of what we experience. The seasons, for example, are not caused by the Earth being closer to or farther from the Sun in any simple way. They are the result of the Earth's tilt combined with its orbit. As the Earth travels around the Sun, different parts of the planet receive varying amounts of sunlight at different times of the year. That's what creates the gradual shift from winter to spring to summer and back again. So even though you don't feel the motion itself, you experience its effects. The changing length of days, the angle of sunlight, the slow transformation of the environment around you. All of these are tied to that steady journey through space. It's a reminder that motion doesn't have to be felt to be real. Sometimes it reveals itself indirectly, through the patterns it creates. There's something else worth noticing here. This journey never pauses, not for a moment. There's no point during the year when the Earth stops and rests before continuing. It's always moving, always progressing along its path. Even as you sleep, even as you sit quietly, even in the stillest moments of your day, you are being carried along that orbit. If you think back to a moment from earlier today or even yesterday, the distance you've travelled since then becomes almost difficult to grasp. Hundreds of thousands, even millions of kilometres, depending on how far back you go. And yet, from your perspective, you've simply gone about your day, moved from one room to another, sat down, stood up, maybe taken a walk. The larger motion remains hidden behind the smaller ones you can feel. There's a quiet contrast there, between the movements you notice and the ones you don't, between the steps you take and the journey you're already on. It also raises an interesting thought. If someone were to ask you how far you've travelled today, you might think in terms of meters or kilometres, a short walk, a drive, perhaps a longer trip. But if you include the Earth's orbit, the answer becomes something entirely different. You've travelled tens of thousands of kilometres through space, without trying, without noticing, without any sensation at all. It's a different way of thinking about movement, not as something you initiate, but as something you're part of, a journey that continues whether you pay attention to it or not. As you remain where you are, comfortable and at rest, the Earth continues along its path, carrying you with it. The Sun remains at the centre of that motion, not pulling you directly, but shaping the path you follow. And all of it happens with such smoothness that it feels like stillness. It might feel at this point like we've already uncovered something quite surprising. You're spinning with the Earth, you're orbiting the Sun. That alone is enough to turn the idea of sitting still into something a little uncertain. But there's another layer quietly waiting underneath all of this, one that shifts the picture again in a way that's even harder to imagine at first, because the Sun itself isn't standing still either. Everything we've talked about so far has been centred around the Sun as if it were fixed in place, like the hub of a wheel with the planets moving neatly around it. And for many everyday purposes, that's a perfectly useful way to think about it. But in reality, the Sun is also moving, and when it moves, it carries the entire solar system along with it, which means that as the Earth orbits the Sun, and as you sit quietly on the Earth, you're also following a much larger path through space, a path that doesn't loop back on itself in a simple circle, but stretches forward continuously like a long, spiralling journey. To begin to picture this, it helps to step a little further back. Our solar system is part of a galaxy, the Milky Way, a vast collection of hundreds of billions of stars all bound together by gravity. The Sun is just one of those stars, and like the others, it is orbiting the centre of the galaxy. That motion is not slow. In fact, the Sun, along with all the planets, asteroids and everything else gravitationally tied to it, is travelling at roughly 828,000 kilometres per hour around the centre of the Milky Way. That's about 230 kilometres every second. Which means that while you've been listening to this, while your thoughts have been gently following along, you've already travelled thousands of kilometres through the galaxy. And just like before, you don't feel any of it. Because once again, everything around you is moving with you. The Earth is still spinning. The Earth is still orbiting the Sun. But now, the entire system is also moving together, following the Sun as it traces a path around the galactic centre. You might imagine it like this. If the Earth's orbit around the Sun is a circle, and the Sun were perfectly still, then that circle would remain neatly closed, repeating year after year. But because the Sun is moving forward through space, the Earth's path becomes something more like a spiral, not looping back to the exact same place, but advancing continuously. Each year you return to roughly the same position relative to the Sun, but not the same position in the galaxy. You are always somewhere new. There's something quietly fascinating about that. The idea that even though our calendars repeat, even though seasons come and go in familiar cycles, the larger journey never circles back. You are never exactly where you were before. Not in space, not in the galaxy, not in the wider universe. Every moment carries you forward. Now, just as before, the reason this motion feels invisible comes down to the same principles. Smoothness, consistency, shared movement. The Sun doesn't suddenly lurch forward or slow down in a way that your body could detect. Its motion through the galaxy is steady and continuous, and because the entire solar system is gravitationally bound to it, everything moves together. There's no wind rushing past you at hundreds of thousands of kilometers per hour. No sensation of being pulled along. No signal to your senses that something extraordinary is happening. From where you are, everything still feels calm, still grounded, still at rest. But if you could somehow step outside of this system far enough away to watch it from a distance, the picture would look very different. You would see the Sun moving through the galaxy, not alone, but with a kind of trailing structure behind it. The planets orbiting as they go, the Earth tracing its spiral path, the entire system advancing through space like a quiet, continuous journey, and you, somewhere on that small blue planet moving along with it. There's also a gentle shift in perspective that happens here. Up until now, it might have felt like you were moving around something, around the Earth's axis, around the Sun, but now you're also moving with something, following the Sun, carried along by it. It's no longer just circular motion, it's directional, forward, ongoing, without pause. This raises an interesting thought. If everything is moving together, how would you ever know? The answer, once again, is that you wouldn't. Not directly. Your senses are designed to detect local changes, not vast, uniform motion shared across enormous distances. So the larger the system you're part of, and the more smoothly it moves, the more invisible that motion becomes. It fades into the background, becomes the default, and your experience of stillness remains intact. There's a quiet elegance to that. The faster and more expansive the motion, the more likely it is to go unnoticed. What feels stable and unmoving is often part of something far more dynamic. As you sit or lie where you are now, perhaps feeling completely still, you are part of a layered motion that extends far beyond anything you can sense directly. You are spinning with the Earth, you are orbiting the Sun, and you are following the Sun through the galaxy. All at once, all continuously, all without interruption. If you could zoom out far enough, past the Sun, past the outer planets, past the distant edges of the solar system where sunlight becomes faint and thin, the view would begin to change in a way that's difficult to picture all at once. The familiar structure of orbits and planets would shrink into something much smaller, almost delicate, as the wider shape of our galaxy comes into focus. A vast, slowly rotating system of stars, gas and dust, stretching across unimaginable distances. This is the Milky Way, and somewhere within it, not at the centre, not at the edge, but in a quiet region about halfway out, the Sun is moving, which means once again that you are moving too, not just around the Sun, not just spinning with the Earth, but travelling through the galaxy itself, following a path that takes hundreds of millions of years to complete. To begin to grasp this, It helps to imagine scale in a slightly different way. The Earth's orbit around the Sun feels large when you think about it in kilometres, but it repeats every year. It's something you can relate to through seasons and time. The Sun's journey around the galaxy is something else entirely. One full orbit around the centre of the Milky Way takes roughly 225 to 250 million years. That's sometimes called a galactic year, which means that since the time dinosaurs walked the Earth, the Sun has completed only about one full trip around the galaxy. That's how large this motion is. And yet, even at that immense scale, the speed involved is enormous. As mentioned earlier, the Sun, along with the entire solar system, is travelling at around 828,000 kilometres per hour as it orbits the galactic centre. That's fast enough to circle the Earth many times in a single hour. But once again, none of that speed is something you feel, because just like before, everything around you is part of the same motion. The Earth, the Moon, the planets, even the distant objects bound to our solar system, all of it is moving together as one system, carried along by the Sun's path. There's no separation between you and that motion, no relative difference that would make it noticeable, just a continuous shared journey. Now, what exactly are we orbiting? At the centre of the Milky Way lies a region known as Sagittarius A star, a supermassive black hole with a mass millions of times greater than the Sun. It's not pulling everything inward like a vacuum in the way it's sometimes imagined, but it does play a central role in the gravitational structure of the galaxy. The stars, including our Sun, move under the combined gravitational influence of everything in the galaxy, with that central region acting as a kind of anchor point. So the path the Sun follows is not a perfect circle, but a complex orbit shaped by the mass of billions of stars and the distribution of matter throughout the galaxy. And within that motion, the Earth continues its smaller cycles, spinning daily, orbiting yearly, all nested inside this much larger journey. It's like being part of multiple overlapping paths at once, each with its own scale and rhythm. There's something quietly humbling about that. The idea that your everyday experience, the simple feeling of sitting still, exists within layers of motion that stretch across such vast distances and timescales. And yet, despite all of that, your immediate experience remains calm, grounded, unchanging. Because from your perspective, nothing is shifting. Your room stays in place. The objects around you don't drift away. The ground beneath you feels solid and still. That's because all of this motion is shared. It's not something happening to you from the outside. It's something you are part of. To make this a little easier to picture, imagine being inside a large, smoothly moving train. Not one with windows showing the outside world rushing past, but one where everything inside moves together perfectly. You, the seats, the air, everything. If the train moves at a constant speed, and there are no vibrations, no sounds of motion, no external reference points, it would feel exactly like standing still. Now imagine that train is not just moving along a straight track, but following a vast, gentle curve that takes millions of years to complete, and everything inside it is unaware of that curve because it's so gradual. That's closer to what's happening with the Sun's orbit around the galaxy. You are inside that motion, carried along without any sensation of movement. And because the scale is so large, the curvature of the path is almost impossible to notice from within. There's another small detail that adds to this picture. The Sun doesn't move alone. It travels with a kind of local group of stars, sometimes referred to as a stellar neighbourhood. These stars share similar motions through the galaxy, creating a kind of collective flow. So even on the scale of nearby stars, there is a sense of shared movement, a kind of gentle drift through the galaxy. And again, because everything in your immediate environment is part of that same flow, it reinforces the illusion of stillness. Nothing appears to move relative to you. So your brain continues to interpret the world as stable, as unmoving. But step far enough back, and the entire scene transforms. You would see the galaxy rotating, stars tracing their paths around the centre, vast clouds of gas shifting slowly over time, and within that you would see the sun carrying its planets along a long continuous orbit. And somewhere on one of those planets you would be moving along with it, quietly, effortlessly, without ever feeling the speed. There's also something interesting about how time fits into this. The motions we've been talking about so far unfold over very different timescales. The Earth's rotation takes a day. Its orbit around the Sun takes a year. But this galactic orbit takes hundreds of millions of years, which means that from a human perspective, it doesn't feel like motion at all. It feels like permanence. The stars in the sky appear fixed, forming patterns that seem unchanging over a lifetime. But those patterns are slowly shifting. The stars are moving. It's just happening so gradually that it becomes invisible to us. Our sense of time is too short to notice it directly, and so, once again, motion hides itself. Not because it isn't there, but because it unfolds on a scale that our senses aren't designed to track. As you remain where you are now, perhaps feeling completely at rest, you are part of this immense ongoing journey. You are orbiting the centre of the galaxy. You are travelling at hundreds of thousands of kilometres per hour, and yet from your perspective, nothing is moving. That contrast between the vastness of what's happening and the quiet simplicity of how it feels is something we carry with us all the time. We live inside these motions, we're shaped by them, but we rarely notice them. Beyond the gentle rotation of stars around the galactic centre, there's another layer waiting quietly in the background, one that's even harder to picture because it has no obvious reference point at all. Up until now, it might have been comforting to imagine that while everything inside the galaxy is moving, the galaxy itself is, in some sense, steady, a kind of vast stage on which all these motions unfold. But that isn't quite how it works. The Milky Way is moving too, not in a tight orbit like the Earth around the Sun, and not in a simple, clearly defined path, but drifting, interacting, and flowing through an even larger structure that stretches across the universe, a structure sometimes described as the cosmic web. This web is made up of immense filaments of galaxies, clusters, and vast empty regions called voids. If you could see it from far enough away, it wouldn't look like a neat pattern or a tidy system. It would look more like a loose network, threads of matter stretching across enormous distances, with galaxies gathered along those threads like tiny points of light. And within that network, our galaxy is not fixed. It is moving. To understand this motion, it helps to step even further back in scale. Galaxies are not isolated. They exist in groups and clusters, bound together by gravity. The Milky Way, for example, is part of a small collection known as the Local Group, which includes the nearby Andromeda Galaxy and dozens of smaller galaxies. These galaxies are not simply sitting beside one another. They are interacting, slowly moving, influenced by each other's gravity, tracing paths that will eventually bring some of them closer together. In fact, the Milky Way and Andromeda are on a long, gradual course toward one another, expected to merge billions of years from now. But even that interaction is only part of the story. The entire local group itself is moving. It is being pulled by the gravitational influence of larger structures, drifting toward a region of space known as the Great Attractor, a massive concentration of galaxies and matter that exerts a subtle but persistent pull. So now, layered on top of everything else, there is yet another motion. The Earth spins. The Earth orbits the Sun. The Sun orbits the centre of the galaxy. The galaxy moves within the local group, and the local group drifts through the cosmic web. All of these motions are happening at once. All of them are continuous. And still, from where you are, everything feels calm, still, unmoving. There's something quietly remarkable about that. The idea that you can be part of so many overlapping journeys, each one unfolding on a different scale, and yet experience none of them directly. If you could step outside of all of this, far enough to see the motion clearly, the picture would be almost impossible to hold in your mind all at once. You would see galaxies drifting along filaments, clusters pulling on one another, vast regions of space expanding and stretching. You would see the Milky Way moving, not as a static shape, but as part of a larger flow. And within it, you would see the sun carrying its planets, and within that the Earth turning, and within that you. It becomes a kind of nested motion, each layer contained within the next, each one adding to the overall journey. And yet, at your scale, none of that motion feels urgent, none of it feels fast. Because once again, everything around you shares that same movement. There's no contrast, no sudden change, no signal for your senses to detect, so your experience remains grounded, stable, still. There's also an important detail here that changes how we think about motion on this scale. Unlike the neat, repeating orbits we see closer to home, the movement of galaxies through the cosmic web is not a simple loop. It doesn't bring you back to where you started. It's more like a drift, a gradual, ongoing shift through space, influenced by gravity, shaped by the distribution of matter, and guided by the expansion of the universe itself. So while the Earth completes a rotation each day and an orbit each year, and the Sun completes a galactic orbit over hundreds of millions of years, the larger motion of the galaxy is not cyclical in the same way. It's directional, evolving, always moving forward into new regions of space. There's a subtle difference there, one that becomes more noticeable the further out you look. The closer you are to a system, the more structured and predictable the motion appears. The farther out you go, the more complex and open-ended it becomes, and somewhere within all of that, you remain part of the motion. Not as an observer standing outside it, but as a participant carried along by it. There's also something quietly humbling about how little of this we can perceive directly. The stars in the night sky appear fixed, forming patterns that seem unchanged across generations. But in reality, those stars are moving. The galaxy is shifting. The entire structure is evolving over time. It's just happening so slowly and on such a large scale that it becomes invisible to us. Our senses are not designed to track motion across millions or billions of years. They are tuned to the present, to immediate changes, to what matters right now. And so, the larger motions fade into the background. They become part of the stage, rather than something we notice. But even if you can't feel it, even if you can't see it directly, it's still happening. Right now, you're drifting through the galaxy, and the galaxy is drifting through the universe, and all of it is happening with such smoothness, such consistency, that it feels like nothing is moving at all. There's a quiet contrast here between the simplicity of your immediate experience and the complexity of what's actually happening, between the feeling of stillness and the reality of motion. Take a moment and notice the quiet around you, not in a dramatic way, not searching for anything unusual, just the ordinary sense of stillness that comes when nothing seems to be happening. The room holds its shape, objects remain where they are, and your body feels settled into place. It's a very convincing feeling, the sense that things are stable, unmoving, exactly as they should be. And yet, by now, there's a small shift in perspective beginning to settle in. Because once you start looking a little closer, that stillness begins to soften. Not disappear, not vanish entirely, but become something a little more layered. Everything is moving, even when it looks completely still. That idea might seem obvious after everything we've explored so far, but there's something deeper to it than just large-scale motion. It's not only the Earth spinning or orbiting, not only the sun moving through the galaxy, not only the galaxy drifting through the cosmic web. It goes further than that, much closer, much smaller. Because motion doesn't only exist on the scale of planets and stars, it exists in everything, right down to the smallest levels you can imagine. Consider something simple. A glass of water sitting on a table. From where you are, it looks perfectly still. The surface is calm, the shape doesn't change, nothing about it suggests movement. But inside that glass, the water molecules are in constant motion. They are vibrating, shifting, colliding with one another, moving in ways that never fully stop. Even at room temperature, that motion is continuous. It doesn't pause when you look away. It doesn't settle into complete stillness. It only appears that way from the outside. The same is true for the air around you. It might feel calm, especially if there's no breeze, but the molecules in that air are moving in all directions, bouncing, colliding, exchanging energy. Every breath you take is part of that motion. And then there's your own body. Your heart beats, your lungs expand and contract. Your cells carry out countless processes every second. Blood flows, signals travel through your nervous system, muscles adjust in tiny ways to maintain balance. Even when you're completely still, your body's active, moving, constantly. There's something quietly reassuring about that. The idea that stillness doesn't mean inactivity, that beneath the calm surface there is always motion, always activity, always something unfolding. But there's another layer to this idea, one that connects everything we've talked about so far, because all of these small emotions exist within the larger ones. The movement of molecules happens while the Earth spins. The flow of your breath happens while the planet orbits the sun. Your heartbeat continues while the solar system travels through the galaxy. All of these motions are nested inside one another. None of them interrupt the others, they simply coexist. And because of that, the overall experience remains calm, stable, still. It's a bit like listening to music with multiple layers, a steady rhythm, a melody, perhaps a background harmony. Each part is moving in its own way, but together they create something that feels smooth and unified. You don't focus on every individual note, you experience the whole, and in that experience the complexity becomes simplicity. That's what's happening with motion. There are countless layers, from the smallest to the largest, all unfolding at once, but your perception blends them into a single, coherent experience. And that experience feels like stillness. There's also an interesting detail about how your brain handles this. It is constantly predicting what will happen next. Based on past experience, it builds expectations about the world. Objects stay where they are. The ground remains beneath your feet. The room doesn't suddenly shift. These expectations allow you to navigate the world efficiently, without needing to analyze every moment from scratch. But they also reinforce the illusion of stillness, because as long as things behave predictably, your brain doesn't question it. It assumes stability, even when that stability is part of a much larger motion. There's a quiet contrast here, between what is happening and what is noticed, between the constant activity of the world and the calm interpretation your mind creates. And neither of those is wrong. The motion is real. The stillness is also real, in the sense that it reflects your experience. They exist together. One doesn't cancel out the other. You're moving through space at incredible speeds, and at the same time, you're resting comfortably, feeling completely still. Both are true. There's something gently grounding about that idea. It means that motion doesn't have to feel chaotic. It doesn't have to be overwhelming. It can be smooth, continuous, almost invisible. Something you're part of without needing to think about it. And perhaps that's why it's so easy to overlook. Because nothing about it demands your attention. There's no sudden shift, no dramatic change, no interruption. Just a quiet, ongoing movement that carries everything along. Even the things we consider fixed are part of that. The ground beneath you is moving. The objects around you are moving. The entire environment is part of a system in motion. But because it all moves together, it feels like stability. It feels like home. There's also a subtle shift in how you might begin to think about stillness itself. Instead of being the absence of motion, it becomes something else. A kind of balance. A state where motion is present but not noticeable. Where everything moves together in a way that cancels out the sensation of movement. That kind of stillness is not empty. It's full of activity, just hidden from view. And as you remain where you are now, perhaps feeling that quiet sense of rest, you are part of all of it. The small motions, the large ones, the ones you can feel, the ones you can't, all happening at once, all unfolding without interruption. Imagine asking a very simple question. How fast am I moving right now? It sounds straightforward. You might expect a single number, something clear, definite, easy to hold on to. But as soon as you begin to look a little closer, that question starts to shift, because the answer depends on something you might not immediately think about. Compared to what? Speed, as it turns out, is not an absolute thing. It doesn't exist on its own, floating independently in the universe. It always describes motion relative to something else. Without that reference point, the idea of speed begins to lose its meaning. You can see this in everyday situations. If you're sitting in a parked car, your speed relative to the road is 0. But if another car passes by, your speed relative to that car is suddenly something different. If you're walking forward inside a moving train, your speed relative to the train might be slow, but relative to the ground outside, it's faster. And if someone were watching from far above, your motion would combine both of those movements at once. None of those perspectives are wrong. They're simply different ways of describing the same situation. And that's the key idea. Motion is always relative. Now bring that idea back to where you are right now. If you measure your speed relative to the chair you're sitting on, or the floor beneath you, you're not moving at all. From that perspective, your speed is 0. But if you measure your speed relative to the centre of the Earth, you're rotating along with the planet. Relative to the Sun, you're orbiting at about 107,000 kilometers per hour. Relative to the centre of the Milky Way, you're moving even faster, and relative to the larger structures of the universe, that motion becomes part of something even more complex. So which one is correct? All of them. That's what makes this idea so interesting. There isn't a single, universal answer to how fast you're moving. There are many answers, each depending on the frame of reference you choose. This concept is known as a reference frame. It's simply the point of view from which you measure motion. And once you start thinking in terms of reference frames, the idea of stillness begins to change. Because being still doesn't mean not moving at all. It means not moving relative to your chosen reference. Right now, you feel still because you are at rest relative to your surroundings. The room, the floor, the objects around you, they all share your motion. So from that perspective, nothing is changing. But shift the reference frame, and the picture changes immediately. From the perspective of the sun, you are moving very quickly. From the perspective of the galaxy, faster still. From the perspective of something even farther away, your motion becomes part of an even larger flow, and yet your experience doesn't change. You still feel calm, still grounded, still at rest. There's something quietly fascinating about that. The idea that motion is not something fixed, but something that depends on how you choose to look at it. It also explains why certain situations can feel confusing at first. Think again about that moment in a train when another train begins to move beside you. For a brief second, it can feel like you're the one moving, even if you're not. Your brain is trying to determine which reference frame to use. Is the platform the reference? The other train? Your own train? Until it settles on one, the sensation can feel uncertain. But once it does, everything becomes clear again. You either feel like you're moving, or you feel like you're still, even though the underlying motion hasn't changed. There's a deeper layer to this as well. In everyday life, we tend to choose reference frames that are convenient. The ground beneath us, the room we're in, the planet we live on. These are stable, familiar, and easy to relate to, so we describe motion relative to them. But those choices are not fundamental. They're just practical. If you were living on another planet, you would naturally use that planet as your reference. If you were floating in space, far from any large object, your sense of motion would become much less intuitive. Without a clear reference, it becomes difficult to define what moving even means. And that's where things begin to connect to deeper ideas in physics. because when scientists study motion, especially at very large or very small scales, they often have to choose carefully which reference frame to use. Different frames can reveal different aspects of the same phenomenon, and sometimes switching perspectives can make something complicated become simple, or something simple become complicated. There's also a subtle shift in how we think about speed itself. We often imagine speed as something absolute, a number that exists independently, but in reality, speed is always tied to comparison. It's always about how one thing moves relative to another. Without that comparison, the number has no meaning. You could say you're moving at 100,000 kilometers per hour, but unless you specify relative to what, that number doesn't fully describe anything. It's incomplete. And yet, in everyday life, we rarely notice this. Because our reference frame is so consistent. We live on the Earth. We measure speed relative to the ground. We experience motion in a way that feels stable and intuitive, so the relativity of motion stays hidden, much like the motion itself. There's something quietly elegant about that. The idea that the universe doesn't provide a single fixed answer to how fast you're moving. Instead, it offers many perspectives, each valid in its own way. And your experience depends on which one you choose, even if you don't realize you're choosing at all. You can hold on to that thought. You are still, from one perspective, you're moving incredibly fast from another. Both are true at the same time, there's no contradiction. Just different ways of looking at the same reality. Numbers can be a little deceptive. You hear something like 1,000 kilometers per hour or 100,000, and for a moment it sounds impressive, maybe even overwhelming. But then the number fades into abstraction, becoming just a figure without much meaning attached to it. That's because speed, on its own, is difficult to feel. It needs context, something to compare against. So instead of thinking about these speeds as isolated numbers, it helps to place them side by side, gently, almost like laying them out on a table and noticing how they relate to one another. We'll start small. A typical walking pace is around 5 kilometers per hour. It's the kind of movement you're familiar with. You feel each step, the shifting of your weight, the rhythm of your body moving forward. If you double that speed, perhaps jogging lightly, it becomes more noticeable. Your breathing changes, your muscles engage more actively, the sensation of motion becomes clearer. A car moving through a city might travel at 50 kilometers per hour. On a highway, perhaps 100 or 120. At that point, the motion becomes something you can feel if it changes suddenly, but when it's steady it begins to fade into the background again. Then there are airplanes. A commercial jet typically cruises at around 800 to 900 kilometers per hour. From the outside that seems incredibly fast. But from inside the cabin, once the plane reaches its cruising speed it feels calm, almost still. You can sit, read, rest, and aside from the subtle hum of the engines, there's very little to remind you of the speed. That's the first hint that speed alone doesn't define your experience. Now, place that next to the Earth's rotation. At the equator, around 1,670 kilometers per hour. Faster than a plane, and yet completely unnoticed. Then step up to the Earth's orbit around the Sun, about 107,000 kilometers per hour. At this point, the numbers begin to stretch beyond everyday intuition. It's more than 100 times faster than a jet, and still, there's no sensation, no wind rushing past you, no sense of acceleration, just quiet stillness. Then we move to the motion of the Sun through the Milky Way, roughly 828,000 kilometers per hour. Now we're approaching speeds that feel almost abstract, hundreds of kilometers every second. In the time it takes to blink, you've already traveled farther than most journeys you would take in a day, and yet nothing about your immediate experience changes. The room remains still, your body remains at rest, the sensation of motion remains absent. If we continue this gentle comparison, we can go even further. Galaxies themselves move within clusters, and clusters move within the larger structure of the universe. Some of these motions reach into the millions of kilometers per hour, but even those are not the upper limit. There is a speed in the universe that stands apart from all others, the speed of light. Light travels at approximately 300,000 kilometers per second, not per hour, per second. It's so fast that light from the sun reaches the Earth in about 8 minutes. The light you see from distant stars has been travelling for years, sometimes thousands or millions of years, just to reach your eyes. Compared to that, even the motion of the Earth around the sun begins to feel slow. Even the movement of the galaxy seems measured. The speed of light becomes a kind of boundary, a limit that nothing with mass can reach or exceed. And that gives us a gentle sense of scale. From walking to driving to flying to planetary motion to galactic motion and finally to the speed of light. Each step upward increases the speed dramatically, and yet your experience remains largely the same. Stillness, calm, a sense of being at rest. There's something quietly interesting about that contrast. The fastest speeds you're part of are not the ones you feel. They're the ones that are most consistent, the ones that don't change, the ones that carry everything together. If you were suddenly accelerated to one of these speeds, if there were a sharp change, your body would notice immediately. But because these motions are steady, because they've always been there, they become invisible. There's also a subtle shift in how you might begin to think about speed itself. It's not just about how fast something is moving, it's about how that motion fits into a larger context. A car feels fast compared to walking. A plane feels fast compared to a car. But compared to the Earth's orbit, both are almost still. And compared to the speed of light, even planetary motion feels slow. Each layer changes the meaning of the numbers. Each comparison reshapes your sense of scale. And somewhere within all of that, your own experience remains grounded. You sit, you rest, you breathe. And despite being part of these enormous speeds, you feel completely still. There's a quiet kind of comfort in that. The idea that motion doesn't have to be overwhelming, that even at incredible speeds things can feel calm, stable and steady. As you remain where you are part of all of these layers at once. The smaller speeds you can feel, the larger ones you can't. All overlapping, all continuous, all unfolding without interruption. At some point a quiet question begins to form. All of these speeds, the Earth spinning, the planet orbiting the sun moving through the Milky Way, they sound precise, almost too precise. Numbers like 1,670 kilometers per hour, 107,000 kilometers per hour, hundreds of thousands more on larger scales, and yet no one has ever stood outside the Earth and watched it spin in real time with their own eyes. No one has stepped outside the solar system to measure its path with a stopwatch. So how do we actually know? How do we measure something we can't directly step outside of? The answer, gently, is that we don't measure motion in the way we might measure the length of a table or the height of a wall. We measure it indirectly, we observe patterns, we track changes, and we build a picture from those observations piece by piece until the motion reveals itself. It's a bit like watching shadows move across a room. You might not see the sun moving directly, but you notice how the light shifts, how the shadows stretch and shorten, how the angle changes over time. From those changes, you can begin to understand what's happening. Motion leaves clues, and science is, in many ways, the careful reading of those clues. Let's begin with something familiar, the rotation of the Earth. Long before satellites or modern instruments, people noticed that the sun appeared to rise and set in a regular pattern. Day followed night, night followed day, and the cycle repeated with remarkable consistency. At first, it seemed natural to think that the sun was moving around the Earth, but over time, observations became more detailed. The positions of stars shifted in predictable ways,